Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, subscribers, viewers, and future engineers. There is another problem, particularly a problem with calculus on the applications of the inverse trigonometric functions, and of course algebra and trigonometry. I hope that you can follow the explanations and the solutions, thereby helping you to think of your own when confronted with a similar or related problem. And if you want to anticipate the solution, you may do so by pausing the video. The figure shows a rotating wheel with radius 40 centimeters and a connecting rod AP with length 1.2 meters or 120 centimeters. The pin P slides back and forth along the x-axis as the wheel rotates counterclockwise at a rate of 360 revolutions per minute. Find the angular velocity of the connecting rod, or the rate of change of alpha with respect to time in radians per second when theta is pi over 3 radians. So this is the wheel, rotating wheel. It rotates counterclockwise as indicated. AO or OA is 40 cm and AP is equal to 120 cm or 1.2 meters, so 120 cm. This is denoted by alpha, which changes as the wheel rotates, and alpha will also change. P is moving back and forth like that on the x-axis. So first question, find the angular velocity of the connecting rod, or the rate of change of alpha with respect to time in radians per second when theta is pi over 3. So we will express alpha in terms of theta from the figure. This is the enlarged figure here. This portion, we drop a vertical line on OP so that we can form right triangles. And in this right triangle here, the opposite to theta would be 40 sine theta, and the adjacent side is 40 cosine of theta. Then for this other right triangle, this adjacent side is 120 cosine of alpha, wherein this is alpha. And this is x, entire value of x. So from the figure, sine of alpha is opposite over hypotenuse. So opposite is 40 sine theta over 120, and simplifying that sine theta over 3. Alpha therefore is inverse sine of quantity sine theta over 3. And our guide for the derivative of inverse sine function is that it is derivative of u. So inverse sine of u, imagine that's u, du dt over square root of 1 minus u square. So therefore, the derivative of alpha with respect to t is the derivative of sine theta over 3 with respect to t, and that is 1/3 derivative of sine cosine theta, then the derivative of theta with respect to time d theta dt, divided by square root of 1 minus u square, so square root of 1 minus 1/3 of sine theta quantity square. So we are also given that d theta dt is 360 revolutions per minute, and we will express that to radians per second. So 360 revolutions per minute, 1 minute is 60 seconds, then times quantity 2 pi radians per revolution. So cancel revolution, and the resulting unit would now be radians per second, and that is equal to 12 pi radians per second. We then substitute into this equation here. So we have the derivative of alpha with respect to time, the rate of change of alpha, is equal to 1/3 cosine of theta, and theta is pi over 3 at that instant, times d theta dt, which is 12 pi radians per second, all over square root of 1 minus 1/3 of sine theta and sine pi over 3 quantity square. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2. That's cosine of 60 degrees. So substitute 1/3 times 1/2 times 12 pi over square root of 1 minus 1/3 of square root of 3 over 2. And this is 1/12. And 1 minus 1/12 is 11 over 12. So that would be 2 pi. 12 over 6 is 2. So 2 pi over square root of 1 minus 1 over 12. 2 pi over square root of 11 over 12. Then square root of 12 becomes numerator. So 2 pi square root of 12 over square root of 11. And square root of 12 is 2 square root of 3. So finally, without simplifying and expressing in decimals, the derivative or the rate of change of alpha with respect to time is 4 pi square root of 3 over square root of 11 radians per second. So that's the answer for the first part. We then proceed to the second part. Express the distance x, this distance here, or express the distance x as OP, which is equal to OP, or absolute value of OP in terms of theta. So we have defined it from here. X is 40 cosine theta plus 120 cosine of alpha, but we'll just express it in terms of theta. So from the figure, x is 40 cosine theta plus in this adjacent side is also 100 by Pythagoras theorem, 120 square minus opposite quantity 40 sine theta square, so that we can express it in terms of theta alone. So simplifying, 140 cosine theta plus square root of this side, 120 cosine alpha is also square root of 120 square minus quantity 40 sine of theta by Pythagoras theorem square. So 40 cosine theta plus square root of 120 is 40 times 3 quantity square, and this is minus 40 square sine square theta. So 40 square is common. We factor out square root of 40 square. So what is left is we have 40 on outside, then square root of 3 square, which is 9, minus sine square of theta. Since we can break 9 into 8 plus 1 minus sine square theta, and noting that 1 minus sine square theta is cosine square theta. So we have 40 cosine theta plus 40 square root of 8 plus quantity 1 minus sine square theta, which is equal to cosine square theta. So finally, x is 4, factor out 40 from here, then quantity cosine theta plus square root of 8 plus cosine square theta, and the units is centimeters. Then finally, find an expression for the velocity of the pin P in terms of theta. The velocity of the pin P is dx dt, and we express that in terms of theta because x is given by this expression here. All we have to do is differentiate this with respect to t. So we factor out 40, which is constant. The derivative of cosine is negative sine theta, and the derivative of theta with respect to time is d theta dt. Then plus, we have derivative of square root. Derivative of square root of u is the derivative of u inside with respect to t, all over 2 square root of u. So for the radicand, the derivative by power formula first, 2, then cosine to the 1 of theta, or simply cosine theta, then the derivative of cosine theta after power is derivative of cosine, which is negative sine theta. Then finally, the derivative of theta with respect to time is d theta dt, all over 2 square root of u. We just copy square root of u, which is 8 plus cosine square theta. Cancel out 2, then factor out negative sine theta and d theta dt. Then we have dx dt is negative 40 sine theta d theta dt. What is left here is 1, and here is plus cosine theta over square root of 8 plus cosine square theta. And d theta dt is 12 by radians per second, so substitute dx dt is negative 40 sine theta times 12 pi radians per second times the quantity 1 plus cosine theta over square root of 8 plus cosine squared theta. Finally, we simplify negative 40 times 12 is negative 480 times pi sine theta times quantity 1 plus cosine theta over square root of 8 plus cosine squared theta in centimeters per second. So that's it for this video. I hope that you were able to follow the solutions and the explanations as engineering students. You should be able to follow, especially the derivative of inverse functions. If not, then you will have problems in engineering.